Hello everyone. This video is to show you how to find probabilities when dealing with an exponential distribution. So we're going to use problem 6.65 in your book. Supposing that the number of months before your car battery needs to be replaced follows the exponential distribution with a mean of 50 months. And then we're going to answer these questions. What is the probability that your car battery will need to be replaced within 24 months? Replaced within 30 to 60 months, replaced after 84 months, and then what is the standard distribution? So if you look back in the chapter, they talk about finding what they call lambda, and that's just looking at the mean number of occurrences over the interval. So what we're basically saying for lambda is our mean is 50, so we're going to take 1, divide it by 50, and if we don't want that as January, we're going to say equals 1 divided by 50. And it's still giving us a date. We come up, change this. We want this to be a number. So 0.02 is our lambda. So we can do this two different ways. I'm going to start by filling out the months and just using that exponential distribution function and going all the way down through 86 months. You don't have to do it this way, but I'm going to show you two different ways of doing it. So the first way, again, we're going to use a function, so you can use your function builder, or you can just type in exponential distribution and click on that. First thing they want is our x, so that's our month. The next thing they want is lambda, so we're going to click on B2, and we are going to absolute reference that B2 because we never want our lambda to change. And then we want this to be cumulative because we want to figure out, within 24 months, within 30 to 60 months, after 84 months. So we're going to say true. Then you hit enter. And at this point, it's 0 because it's a month 0. So then you can double click, which is what I did to fill it in, or you can drag it all the way down. All right. Well, that's weird that it didn't fill in. It's there. We'll just... Oh, there they are. Excel just didn't want to show us. Okay. So what is the probability that we're going to replace it within the first 24 months? Not at 24 months, but within the first 24 months. So we can come down here and find that it should be 0.3812. That would be within the first 24 months. So you can do it that way. Or we could simply type in that formula again up here. If you don't want to fill out the table, exponential distribution of 24, because we're going less than 24. Here's my lambda, true. We want the whole accumulation up to 24 months. And that gives us 0.3812, same as we got in the table. Oops, too far. 24, here we go. We'll bold that. Actually, let's highlight. There we go. So now we want to know, what about is it with it being replaced within 30 to 60 months? So here we've got to do a couple of different things. What we can do is we could either do equals, and then we find our 30 month or our 60 month, and we subtract our 30 months. So we take 6 month, the accumulation of month 60 and subtract the accumulation of month 30, and that gives us the difference. So 0.2476. If, again, you don't want to use the table, and again, I'm going to highlight these just so we have them, 30 and 60. If you don't want to use a table, what you're going to have to do is do two different distributions. So you'd have to do exponential distribution, and again, we're doing 60, our lambda, and then true, And then we're going to subtract our exponential distribution of 30, our lambda, and true. And we should get the exact same thing because you're taking that 60 and subtracting the 30. So you could do it that way. This last one, again, you could do, we're looking at month 84, so we come down, find our month 84. So we find that there is an 81% chance, basically, that you're going to have to replace your battery within the first 84 months. So what is the probability that you'll be replacing your battery after 84 months? Well, we simply take 1, because that would be 100%, and subtract our cumulative probability at 84 months. And we get 18.6% or 0.186. If you don't want to use the table, again, you can hit equals 1 minus and then type in that exponential distribution. And we're going to use our lambda, or our x of 84 months, because we're subtracting the accumulation of before 84 months. 2.02 is my lambda, and true. And we should get the same thing. So that's how you would figure out those probabilities using exponential distribution. So finally, what we need to know is, how do we calculate the standard deviation for this distribution? And all that is 1 divided by your lambda. So we take 1 divided by lambda, which is 1 divided by 50. Oops, I need to type equals here. And my standard deviation is 50. So that's how you would find exponential distribution probabilities. You can either use the table or you can simply use the formulas, whichever you are more comfortable with.